So we know we have about 0.2 moles of magnesium. I'll say 0.2 moles, but don't forget to include all of those decimal places that you calculated earlier. If we were to react all of the magnesium to make magnesium oxide, how much oxygen would this require? Remember, the mole-to-mole ratio comes from the balanced equation, and we arrange the ratio to make the units cancel. So in order to react all of the magnesium, we would need about 0.1 moles of O2. This is the theoretical amount of oxygen we would need. Remember, it is not an actual amount. When you are doing limiting reactant problems, it'll really help you if you always distinguish between actual amounts and theoretical amounts. So I suggest that you write whether it's actual or theoretical after the molar quantity. So now we look to see how much oxygen we actually have from step 2. We calculated that we had 0.3125 moles of oxygen. So the actual amount of oxygen that we have is greater than the theoretical amount that we would need for the reaction. So then we know that oxygen is in excess. We have more oxygen than we would need to complete the reaction given the amount of magnesium we have. So if oxygen is our reactant that is in excess, then magnesium must be our reactant that is limiting. Magnesium is the limiting reactant because it would run out first if we reacted all of the oxygen we have. If we had chosen oxygen, then we would use the mole-to-mole ratio to figure out the theoretical amount of magnesium that we would need for the reaction. We would have found that the theoretical amount of magnesium is greater than the actual amount we have. So again, magnesium is the limiting reactant. Step 4. Okay, now the really hard part is over, so give yourself a pat on the back. It's likely that the problem will ask you the amount of product made in the reaction. So we'll figure that out in moles, again using the mole-to-mole ratio. The most important thing to remember here is that we need to use the molar amount of the limiting reactant because it's the reactant that runs out first. All of the limiting reactant will go into making the product, whereas there will be some leftovers of the reactant that is in excess, just like the cheese and burgers. So take the actual amount of the limiting reactant, in this case about 0.2 moles of magnesium. Always remember to use the actual moles you calculated in step 2 and not the theoretical moles that you calculated in step 3. So we use our molar quantity of magnesium to figure out how much of our product, magnesium oxide, we would make. And that's about 0.2 moles of magnesium oxide. Remember to arrange the mole-to-mole ratio so that your units cancel. Again, way to go for making it this far. Usually the problem will ask you for the amount of product created in grams. So convert from moles to grams. No problem. So if we have about 0.2 moles of magnesium oxide and we use the molar mass of magnesium oxide, we calculate that we will have 8.3 grams of magnesium oxide. Don't forget your sig fig. So let's recap how to solve limiting reactant problems. The very first thing you'll need to do is recognize that it's a limiting reactant problem. And that's when you are given the amounts of 2 reactants. Now we're ready to start solving. Step 1, balance the chemical equation. Step 2 is to convert masses to moles. So now you'll know the actual amounts in moles that you have of each of your reactants. Remember, step 2 is actual, real-life, physical amounts. Step 3. Choose any one of your reactants and use the actual molar amount of that reactant to figure out the theoretical amount of the other reactant you would need in order to complete the reaction. If that theoretical amount is less than your actual amount of that reactant that you calculated from step 2, then that reactant is in excess. If that theoretical amount is greater than your actual amount of that reactant that you calculated from step 2, then that reactant is the limiting reactant. Step 4 is to calculate the number of moles of the product that you would create using mole-to-mole ratios and the actual molar amount that you calculated in step 2 of the limiting reactant.
Created using Powtoon.